Hi everybody. Today's lesson is 3-4. It involves dividing exponents. So our learning target says I can apply what I know about division to dividing expressions containing exponents. And we'll see problems like you see in the success criteria. Negative 42x to the fifth divided by 14x to the second. Let's learn how to do that, and we'll answer that one at the end. So here are our rules when we divide with exponents. We're going to use the property of exponents to simplify x to the fifth divided by x to the second. And again, we're going to do this longhand. We're going to write it in expanded form first so we understand why it works, and then we'll learn our shortcut. So when I write this in expanded form, y to the fifth means I line up 5 y's and multiply them. Y squared, or y to the second, I have 2 y's in my denominator. Now I can cross out the variables that cancel each other out. So those can go and those can go. I'm left with 3 y's over 1 equals y to the third. Maybe you guessed it, our shortcut. It's kind of the opposite of what we did when we multiplied. When we added, we're going to use the rule to subtract the exponent in the denominator from the exponent in the numerator. This is what happens when we divide. Y to the fifth over y to the second. We could rewrite that as y to the 5 minus 2 power. And our solution is y to the third. Let's practice one. 8 to the ninth over 8 to the fifth. Again, the rule says subtract the exponent in the denominator from the exponent in the numerator. So let's write it. 8 to the ninth over 8 to the fifth. I can rewrite that 8 to the 9 minus 5 equals 8 to the fourth. All right, looks like my marker's getting a little bit dry, but it's still 8 to the fourth. All right. Now what happens if we have fractions with exponents? Let's use the properties of exponents to simplify x to the fourth over 7, that whole quantity, squared. Here are our steps. We're going to distribute that exponent to everything inside the parentheses first. So when we square something, we take it times itself. So x to the fourth squared means x to the fourth times x to the fourth. Now do not forget, if you do it to the numerator, you have to do it to the denominator too. So 7 squared is 7 times 7. Now let's keep writing it in expanded notation. X to the fourth means 1, 2, 3, 4 x's times another x to the fourth means 4 more x's. And then when we multiply our coefficients, we count how many variables there are, and that is our new exponent. So 1, 2, 3, 4, 5, 6, 7, 8 x's. I have x to the eighth over 49. And that is my simplified expression. And as always, there is a shortcut. The rule still says distribute the exponent outside the parentheses to everything inside. And then we have to remember our taking a power to a power rule. We multiply the exponents together. Our base doesn't change. So we're going to jump right to x to the fourth. When they're squaring that, we know from what we learned last time, we can multiply the exponents. So x to the 4 times 2. And again, do not forget, if you're squaring it, you have to do it to the denominator too. So 7 squared. And here we have 4 times 2 is x to the 8th over 49. Same answer as we got when we wrote it in expanded form and did it the long way. But just remember, power to a power, we multiply. And the other thing, if you do it to the numerator, you do it to the denominator. Let's do an example problem. 5z to the 6th over 6th, that quantity cubed. So now our rules say we can distribute the exponent outside the parentheses to everything inside. And then remember, when you take a power to a power, we multiply. So what does that mean? I can take 5, and I'm cubing it, times z to the 6 times 3. Do not forget your denominator. 6 cubed. I can also break that down with my coefficient here times z6. Kind of backing up a step there just to show you. 5 to the 3rd power is 125. 6 to the 3rd power is 216 times z to the 6 times 3. Z 6 times 3. Bottom line, final answer, 125 over 216 times z to the 18th power. Just remember, we took our cubing to our coefficients. We took our cubing to our variable that was already taken to a power, and we just worked through the math. You can use your calculators on this for sure. And then remember, power to a power is multiplying. So there was our final answer. All right, let's try a different type of problem.